solve this question. The number of natural numbers of 2 or more than 2 digits in which digits from left to right are in increasing order. Let's say I have to find the natural numbers of 2 and more digits. So natural numbers can be consist of 2 digits, right? More than 2 are 3 digits, 4 digits, 5 digits, 6, 7 and 8 and 9 digits. This is the maximum number of digits I can use because digits can be from 0 to 9. I can use these 2 digits. Then numbers of this type or 2 digits would be like, for example, these are AB. Condition is that the natural numbers, I have to form the natural numbers such that when I go from left to right, digits would be in increasing order. Digits would be in increasing order. It means that A has to be less than B, right? And if 3-digit number is A, B, C, then A must be less than B, must be less than C. So I have to find the numbers of such type. Now, I can choose numbers or I can choose digits from 0 to 9, right? So digits available to choose are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now just listen carefully. If I choose any 2 digits, for example, I have chosen 3 and 4. If I choose any 2 digits, I would get one unique number of such type in which A is less than B, right? Or the other combination of this number can be 4, 3. If I choose 2 digits, there can be 2 numbers. There can be 2 numbers formed from these 2 digits, that is 34 or 43. But only one case would be acceptable in which B is greater than 3, or that number would be 34, right? So I get the one such number on selecting any 2 digits. For example, if I choose 86, so I can form 2 numbers, 86 and 68. Yes, this is acceptable, this is not, because in this number B is greater than A. So we can say if I choose any 2 digits, among these from these digits, I would get one such unique number. So the number of such type of numbers would be only the selection of 2 digits from these available digits, right? But listen carefully. If I choose 0 in any of the number, I would get, for example, I chose 3 and 0. Also 0 and 3 can be made. In which B is greater than A. So this is acceptable, this is not. But mind you, it's a 2-digit number. If I choose 0, 3 will become a 1-digit number. So we cannot choose 0 with any of the digits. But we can say the digits to choose from are only from 1 to 9. We cannot choose 0. So digits available are from 1 to 9, not 0 to 9. So the number of such unique numbers would be selection of 2 digits, and number of this type, that is 3-digit numbers, would be selection of any 3 digits. For example, if I choose 3, 8 and 9, right? So from these 3, 8, 9, how many numbers are possible? Relative arrangement of these 3 digits, which is 3 factorial or 6. But only one unique number would be in this pattern, in which A is less than B and B is less than C. Only 389 is the acceptable number. So we can say the selection of any 3 digits out of 9 digits would be the number of such natural numbers. So the total number of such numbers would be 2-digit numbers How many 2-digit numbers would be there? Selection of 2 digit out of 9 available units, because 1 to 9 are 9 digits. 3 digits number would be 9C3, 4 digit numbers would be 9C4, 5 digit numbers 9C5, 6 9C6, 7 is 9C7, and 8 9C8, and 9 are when I am choosing all the 9 digits out of 9 available digits. So the total number of ways would be 9C2 plus 9C3 plus 9C4, or sum of these up till 9C9. This is the expression. I know this expression. It is nothing but the sum of the binomial coefficients. I know NC0 plus NC1 plus NC2 up till NCn is given as 2 raised to the power n. Sum of the binomial coefficients is given as 2 raised to the power n, right? So the sum of 9, if n is equal to 9, so 9C0, 9C1 and up till 9C2, 9C3 and up till 9C9 is given as is given as 2 raised to the power 9, right? And I have to find the value of this from 9C2 till 9C9. 9C0 I know is 1, 9C1 I know is 9, sum of these two is 10. So the value of this expression would be 2 raised to the power 9 minus 10, and 2 raised to the power 9 is 512 minus 10 is 502. So the correct answer to this question would be 502 such natural numbers would be possible. Correct answer is option C.